Hello. Now this video contains some numericals on scalars and vectors. We'll be basically considering the vector part, and later on we'll be dealing with scalars. So the first question gives three forces which are acting simultaneously at a point. Let the point be O. So one of those forces is suppose 200 Newton acting at the point O, and it is acting at an angle with respect to a horizontal line passing through the point O, and that angle is 30 degrees. Then the horizontal line represented by CO and the initial point of the vector at A. Now there's another vector of 400 newtons, the second vector, and that is acting at an angle 60 degrees, such that A and the second vector, let us say it starts from the point B, they are making an angle of 90 degrees with respect to one another. Now we have to find a third force which will have such that it will have uh, the resultant to be lying along the line OX, that is continued along CO. So OX is the horizontal line extended CO line. So the resultant of all these forces has to lie on that line. So we need to find the vector, the third vector. Now such that this simply means that the resultant of the vectors, the third force, we also need to find the minimum third force. So the minimum force that can act on the two vectors, that is AO vector and BO vector, so the minimum force that must act should be in such a direction so that the final resultant value will be along OX. Now this simply means that the resultant of OA vector and OB vector, they will obviously have a resultant, so that resultant must be acted upon by the third vector, the third force, right, such that the resultant is to be given along the line OX, along the horizontal line OX, the final vector, that is. So in order to find that, first of all let us obtain the resultant of the given two vectors. The second vector continues in the forward direction. We can take the BO along the forward direction and AO in the forward direction as well. We represent them right there, and they are at normal at 90 degrees with respect to one another. Now this simply results in another vector, that is the resultant, and we can obtain it by parallelogram law of vector addition. Here the parallelogram is just a rectangle whose resultant is diagonally placed. We take that resultant to be equal to, let us suppose, R1 vector. We'll take it as R1 instead of R, which will be convenient. So R1 vector is along the line OR, right, and it is the resultant of the two forces 400 and 200 Newton, which are acting normal to one another. So 200 squared plus 400 squared, and the square root of it, because they are at 90 degrees, so simple Pythagorean equation. So that gives me 200 root 5 Newton. This is the value of resultant. Now this resultant will obviously be making a certain angle. Now the third force, in order to be minimum, has to be along a straight line. Okay, and it drops on the OX direction at the point X prime. The minimum value can be obtained by a straight line, not any other line. You can have any oblique line from R to the OX line, but Rx prime will be dropped perpendicularly, normally or perpendicularly, so as to give the minimum, the shortest distance between the resultant. The resultant is obviously, the final resultant is obviously along OX now, that is OX prime. So if R1 makes an angle of alpha with respect to the uh, 200 Newton vector, right? So we need to find this value of alpha. In order to find the value of alpha, we just put the value, that is tan alpha is equal to the value that is 400 sine of 90 degrees. 90 degrees, that is the angle between the two vectors given, that is the AO and BO vectors. And in the denominator we have 200 plus 400 cos 90. Sine 90 goes to 1, cos 90 goes to 0, so all we are left with is 400 divided by 200, that is equal to 2. So tan alpha being 2, we can just say alpha is equal to tan inverse of 2, that is equal to somewhere around 63, yes, 63.43, if I'm not wrong. You can check for yourself. So it is approximately 63.43 degrees. Now the alpha being 63.43, we have an angle phi that R1 makes. So phi is that angle which R1 vector is the resultant of first two vectors makes with respect to the horizontal line OX, along which the final resultant vector lies, that is OX prime. So phi is equal to the whole angle, that is alpha, that we have just obtained. So, and the other angle, the smaller angle, that is directly vertically opposite to 30 degrees, so it is alpha minus 30 degrees. You can check from the geometry. And alpha was just obtained to be 63.43 minus 30 degrees, that gives me 33.43 degrees. So this is the value of phi. Now from the value of phi we can consider the triangle. In the triangle O, R and X prime, yes, that's the triangle, and from that triangle we have the value of sine phi to be equal to the perpendicular, that is Rx primed, divided by the hypotenuse, that is OR. Now Rx prime divided by OR, Rx prime, remember, is the third vector that we need to find, and this is just R1 vector. You can just write it in scalar form, that is R1 in terms of magnitude. So the third vector that was to be obtained, that is the magnitude of the third vector Rx primed, is R1 times of sine phi, that is R1 we had obtained it previously to be equal to 200 root 5 times of sine of the angle, that is 33.43 degrees. This roughly equates to 246.33 Newton. You can also verify that. You can use the calculator for that, and let me write it down here, that is 246.33 Newton. And obviously, as you can see, this value or this vector has to act vertically downward with respect to the resultant that has been obtained for the first two vectors. So that's how we find the third vector, the minimum force that is required. So let's just switch over to the next question. The next question involves a rigid support from which we have a given mass suspended. The mass is 5 kgs. Now this 5 kg is acted upon by the gravitational force, so 5 kgf is the force acting downward. Remember, 1 kgf is 9.8 newtons, so 5 kgf is obviously 5 times of 9.8. Now this is acted upon by a force such that, and the point of suspension from which this mass is suspended, the wire is 10 or the string is 10 meters long. Now a force is acted upon such that it displaces to a certain point where it lies in equilibrium. This is the equilibrium position, or the for the maximum extension or the maximum extended position of the given object. Now it is constrained to a string, so a tension definitely acts along the string, and this position from which it has been displaced from the vertical line to the extreme point is 5 meters. Okay, so the displacement is 5 meters from the vertical line of suspension, from the initial vertical line of suspension. Now obviously it is raised to a certain height, and that height is that length is no more 10 meters. The 10 meters is the string along which it has shifted. So this value is obviously 10 squared minus 5 squared, taking the square root of that from Pythagoras theorem. So this comes out to be 5 root 3 meters. Now the suspension, obviously now it is suspended at an angle in that equilibrium position. So this force is to be obtained. We need to calculate the value of this force. Now how do we do that? So under equilibrium condition, that is at the extreme point that it has traveled, the force has acted upon and the tension acts along the string. So the tension can now be taken along the rectangular components where the angle is theta, and we have the cosine component to be acting exactly opposite to the weight of the object, and the sine component to be acting exactly opposite to the force that was applied. Now remember, this is equilibrium condition, so we just need to stick to the figure and write down our equations. So I just draw a free body diagram for that. So mg acts downwards, t cos theta acts in the upward direction, t the force acts in the right hand side, and t sine theta acts exactly opposite to the force. Now this is the equilibrium condition, so t sine theta is equal to the force, and we have t cos theta to be equal to the weight of the object, that is m times of g. Now just taking the ratio of both the sides, we just cancel out the t part, and therefore we have f is equal to mg gets cross multiplied times of tan theta, where tan theta is obviously sin theta by cos theta, and this is equal to m, that is the mass, times of the acceleration due to gravity at a point is approximately 9.8, and the angle from that triangle, we have tan theta to be equal to the perpendicular 5 divided by the base, that is equal to 5 root 3. So the 5's get cancelled out. 5 times of 9.8 is 49 divided by root 3. Now we can just put the value of root 3 over there. So 49 divided by root 3 is 1.732. That gives me nearly to be equal to I should say 28.29 newtons. Okay, so let's move over to the next question. So the next problem involves finding the resultant of a few forces that are acting at a point. So the resultant of the forces that are acting at the same time at the same point. So one of the forces is 1 root 2 newtons, and it is acting along the northeast direction, and the other force is 9.8 times of root 2 newton, and that is acting along the northwest direction, and the final force is of the value of 2 kilogram force, that is 2 kgf. And 2 kgf, as I have told you, 1 kgf is equal to 9.8 newtons, so 2 kgf is equal to 2 times of 9.8. 1 kgf is equal to 9.8 newtons. So this equates to 19.6 newton, and this is acting in the south direction. So we draw the axis, the directions over here. So that is the north, east, west and south. So a force acting along the northwest is simply 1 root 2 newton at 45 degrees angle with respect to both the axes, that is north and east. Northeast means exactly bisecting the north and east directions. So 9.8 root 2 again exactly in the northwest, so 45 degrees over there, northeast and northwest. And yes, that's equal to 45 degrees when it's between two given directions exactly in the middle. And finally 19.6 newton in the south direction. Now easily we can resolve these vectors into rectangular components. The rectangular components are obviously one of them is acting along the horizontal direction, that is the cosine part, and the sine part in the vertical direction. So 9.8 root 2 cos 45 and 9.8 root 2 sine 45 act in the west and the north directions. Similarly, we have 1 root 2 times of cos 45 in the east and 1 root 2 sine 45. Let me rewrite it again for clarity. 1 root 2 sine 45 in the northern direction. So we just draw these vectors properly now once again. So these are the axis, that is north, east, west, south. So sine 45 is nothing but 1 by root 2, which is also equal to cos 45 degrees, and 1 root 2 sine 45 or cos 45 in both the components that we have is simply 1 root 2 times of 1 by root 2. So the root 2's get cancelled and we have 1. Similarly for 9.8 root 2, either sine or cosine of 45 is 1 by root 2. So again that gives me 9.8. So what we have is 9.8 in the north direction, 1 newton in the north direction, 19.6 in the south, 9.8 in the west and 1 in the east direction, all in newtons. So these are the forces finally, and exactly opposite forces, the greater force will cancel the shorter one or the lesser one. So the resultant of the north, east and west directions will lie in the west, because the west has greater value, greater magnitude. 9.8 minus 1, that is 8.8 newton in the west direction. And similarly for north and south, as you can see, 19.6 is the greater force, so 19.6 minus of the two forces put together in the north direction, that is 9.1 plus 8. So this also results in 8.8 Newton in the south direction. So one of them in the west and the other in the south, and obviously they are of equal magnitude now, so both the lengths will be the same, and the resultant will be exactly bisecting both the two vectors which are acting at normal directions now, west and south. They are normally placed. So 8.8 in the west and 8.8 in the south, the angle between them being 90 degrees. So the resultant force, we can use the triangle or parallelogram law of vector addition. So that is 8.8 squared plus 8.8 squared, a square plus b square plus 2ab cos theta. So 2 times of 8.8 squared cos 90. So cos 90 goes to 0, and we are left with 2 times of 8.8 squared root over. So that gives me 8.8 root 2 in Newton. So the resultant vector over there is just 8.8 root 2 newtons, and because it bisects the angle, it's exactly at 45 degrees with respect to, so it is acting in the southwest direction. You must mention that. And the final problem that we have over here, it's actually a proof that we need to obtain. So we have three axes over here, the x, y and the z axis, and a vector, given vector, suppose it is the a vector, let us take it as a vector, and it is said that this a vector makes an angle of alpha, beta and gamma with respect to all the axes, that is x, y and z. So we just need to prove that sine squared alpha plus sine squared beta plus sine squared gamma equates to 2. Now in order to do that, we proceed as follows. So the components, the rectangular components of the given vector, rectangular components of a vector along the axis can be just represented like this, that we usually do. That is, a vector is equal to the x component I cap plus the y component j cap plus z component k cap. So this is equal to the ax, ay, az will have the values of ax is equal to a cos alpha, because that is the angle it makes with the x-axis, plus a cos beta, where beta is the angle it makes with the y-axis, and finally a cos gamma, where gamma is the angle with respect to the z-axis. So the resultants, all these can be written, can be squared to find the magnitude, and they would equate to a, as we already know for vectors. So a square cos square alpha plus a square cos square beta plus a square cos square gamma is equal to a square. So we can just take the a square out on the left hand side. So cos square alpha plus cos square beta plus cos square gamma times of a whole multiplied with a is equal to a square. A square on the left, a square on the right get cancelled out, and so we are left with 1 on the right hand side. So that means cos square alpha, cos square beta, cos square gamma added together to give 1 when the angles are alpha, beta, gamma with respect to the x, y and z axis. So just writing it in other way, that is cos square alpha is equal to 1 minus sine square alpha, and cos square beta is 1 minus sine squared beta, and cos square gamma is obviously 1 minus sine squared gamma. Now this is equal to 1, so that will imply 1, we take the ones out, so 1 plus 1 plus 1 minus taken common for all the sine squared parts, sine squared alpha plus sine squared beta, the negative has been taken common, so sine squared beta plus sine squared gamma, that is equal to 1. Simply putting it, we have 3 minus of the bracketed term, that is sine squared alpha plus sine squared beta plus sine squared gamma equates to 1. So finally we can just take it as the 3 stays there, the 1 can come to the other side, so sine square alpha plus sine square beta taken to the other side plus sine squared gamma equal to 3 minus 1, that is definitely equal to 2. That's it. Thanks for watching.